Good morning, one and all. Myself, Ramesh Kumar Reddy, working as Assistant Professor in Electronics and Communication Engineering, B.V. Rao Institute of Technology. Today, I am going to discuss about number systems and their conversions. That is one of the topic present in digital logic design. Okay. Now, coming to that number systems and their conversions. So, what are the different types of number systems? So, we have four types of number systems are there. So, one is decimal number system, binary number system, octal number system, and hexadecimal number system. Okay. So, here for decimal number systems, we use base 10, and for binary number system, we use base 2, and for octal number system, we use base 8. So, the decimal number system is the number system we use every day. Okay. So, now coming to that decimal number systems, we use symbols, that is 10 values. So, from 0 to 9. Okay. And now coming to the binary number system uses digits, 2 values, 0 and 1. Octal number system uses 8 values, 0 to 7. And hexadecimal number system uses 16 values, that is 0 to 9 is the numbers, from A to F is the alphabets, that is A, B, C, D, E, F. Okay, to represent any number, no matter how it is long or small, right? So, now coming to decimal number system. So, what is decimal number system? So, here this number system we use our day-to-day life, right? And here base is 10 for decimal number system. The total number of digits or symbols used in decimal number system is 10. Let us take one example. So, if you take decimal number system 4137 is calculated as, so 4 into 1000 and 1 into 100, 3 into 10 and 7 into 1. So, that means here 4000, this is nothing but thousands positions, hundreds positions and tens positions, and this is units position. If you add this thing, so here 4000 plus 100 plus 30 and 7. So, total will get 4137 only. Now, coming to binary number system. So, second type of number system is binary number system. So, in binary number system, we use two symbols, either 0 and 1, and it is also known as binary digits or bits, and base of this binary number system is 2. And here the weights assigned to bits in this system is powers of 2, that is 2 power 0, 2 power 1, 2 square and so on, 2 power n. So, if you take one example, so if you take 10101 is the binary number system. So, this number is nothing but a least significant bit. So, it is also known as LSB, and this number system is known as most significant bit, and it is also known as MSB. Now, coming to next type of number system, octal number system. So, in this system we use 8 digits, 0 to 8, and its base is 8. So, each position in octal number represents powers of 8. For example, 8 power 0, 8 power 1, 8 square, 8 cube and so on, 8 power n. So, next type of hexadecimal number system is, here base is 16. So, we are using 16 digits. So, first 10 digits are digits of a decimal number system. So, whatever you have learned in the previous decimal number system, that is 0 to 9. So, we use this 0 to 9 itself, and remaining 6 digits are denoted by A, B, C, D, E, F, representing the decimal values 10, 11, 12, 13, 14, 15. So, for example, if you take A, so A is nothing but here 10, and B you can represent as 11, and C you can represent as 12, and D you can represent it as 13, and E you can represent it as 14, and F is 15. So, like that you can represent the numbers by using A, B, C, D, E, F. Now, coming to that conversion from one number system to another number system, let us start with first one. So, first take this decimal to binary number system. So, let us take one example here. So, find the binary equivalent of 56 of 10. So if you take, this is binary number system, right? So just this number is divided by 2. So here 2 into 2 power 18, here remainder is 0. Okay, so 2 into 14, so here remainder is 0. So 2 power 7 and 2 threes, here remainder is 1. If you take 1, here 2 power 1, so here also remainder is 1. So if you take this thing, so now we need to take the values from bottom to top. So finally, what is the value of decimal number 56 converted into a binary? So this is the value. So 1 1 1 0 0 0. So this is the value. So you can cross check this one whether it is correct or not. So just this one, if you take this one, so here 1 1 1, here 0 0 0. So just it is multiplied by 2 power 0, 2 power 1, 2 power 2, like that. So if you take here, so here 2 power 5 plus 2 power 4, 2 3, 2 square plus 0 into 2 power 1 plus 0 into 2 power 0. So if you add these things, that is 32 plus 16 plus 8 plus here 0 plus 0 plus 0. So if you add total, then this will be definitely equivalent to 56. So in this way you can cross check whether this answer is correct or not. So now coming to binary equivalent of this number system. Okay, so let us take one example. So here binary equivalent of number system, but in this number system we use 36.0625. So it is fractional, right? So it is fractional number, fractional decimal number. We need to convert it into a binary number system. So let us start with, first take this 36 divided by 2, right? So 2 18s are on here. So here remainder is 0. Here 2 9s are. Here remainder is 0. Here 2 4s are. So here remainder is 1. Here 2 2s are. So remainder is 0. Here 2 1s are. So this is the value of decimal number system, that is 36 value converted into a binary. We can get this value. So we can write it as a 1000100, right? So now, so this part is completed. Now we can move to fractional part, that is 0.0625. Now we need to multiply with 2. So that equivalent to, what is the value? So 0.0625 into 2, we can multiply this 0.0625 into 2, we can get 0.125. So 0.125, and take this 0 as it is here. Okay, now take this 0.125 here and multiply this number with 2, then you can get 0.125 into 2, that is 0.25. So here 0.25. Now simply shift this 0 here and take this 0.25, and just 0.25 into 2 is equals to 0.5. Okay, now again take this 0 and let us take this 0.5 here. 0.5 into 2 is equals to 1.0. Now shift this one here. Okay, that's it. So now after performing this multiplication like this, we need to take these values from top to bottom. So finally, so what is the decimal number system means? The decimal equivalent value is 36.0625. To convert it into a binary, take these two values here, right? And first of all, write 36 is converted into a binary value. So that is 1 0 0 1 0 0 point. So whatever we have values we are getting here for fractional part, here 0 0 0 1. So this is nothing but to convert the decimal value 36.0625 to binary number system. So finally you can write it as a 36.0625 10 is equivalent to 100.000.0001. So this is value. So you can represent it as a base as 2. Why? Because for binary number system we use base as 2. Yes, now coming to next conversion from decimal to octal number conversion. So here also same, let us take one example here. Find the octal equivalent of 348. So take 348 number and just divide it by 8. So here 32 and 8 3 are 24. Here 4 is the value. Okay, reminder. So again divided by 43 is divided by 8. So again 8 5s are 40 and remainder is 3. So we can't divide it to 5. So finally take this value from bottom to top. So write it as an answer, that is to convert 348 decimal number into a octal number system, we can get this value 534 8. Coming to that next example, so but this time I am taking a fractional decimal number system, so to convert it into a octal. So just before that, whatever we have done previously, so just take here again 36 and it is divided by 8. First of all take this 36, right? So here 8 4s are 32. So here remainder is 4. So now coming to here, take this one, that is 0.225. So take this fractional part, that is 0.225. So this is multiply with 8. So if you multiply 0.255 into 8, so you can get the value as here 2.04. Just shift this 2 here and take this value, fraction value, again multiply this value, that is 0.04 into 8. So if you multiply 0.04 into 8, you can get the value as 0.32. Just shift this 0 here and now multiply this one, 0.32 into 8. So if you multiply 0.32 into 8, here 2.56 is there. Just simply shift here 2 and take this 0.56 into 8 here. So again multiply this 0.56 into 8. So you can get the value as 4.48. So just shift here 4. So like that we need to calculate, just 3 digits are enough. So finally what is the answer for this 36.225 is to convert this decimal number to octal number system. First we have to convert this 36 to octal number, just divided by this 36 by 8, 8 4s are 32 and remainder is 4, so 44. So 44 point, so whatever here the values you are getting here 20248. So final answer is, so if you convert this number system, that is 36.225, you can get this one. So this is the answer for this decimal number system, that is fractional decimal number system. If you convert this fractional decimal number system, this is the answer. Okay. So now coming to hexadecimal number system. So to convert decimal number, so let us take one decimal number system here. 764 is our decimal number system. If you take decimal number system 764, just it is also divided by 16. Yes, 16 4s are 64. Okay. So 12 is the remainder. So 124 is the value. So 16 7s are 112. So final remainder is 12. So again divided by this 47 with 16. So 16 2s are 32 and you can get remainder as 15. So as we know, we need to represent after 9 number, that means after digit 9, 10, 11, 12. So 10 is nothing but in hexadecimal number A, in 11 is nothing but B, here 12 C, 13 is D and 14 is E and 15 is F. So like that. So here we are getting, so here 12 means we can represent it as a C and here 15 is we can represent it as a F. So final answer is to convert 764 decimal number to octal. So we can get 2 F C and base is 16. So this is your answer. So let us take one more example. So this time I am taking a fractional decimal number system. So here let us start with 246.05. So here first take 246.05 05 is your decimal number system. So let us take with 246.5, just multiply, just divide it by 16. So 16 ones are 16. Okay. So next here remainder is 86. So 16 5s are 86. Here remainder is 6. 16 5s are 80. So remainder is 6. So now you can represent here 15 is there. So according to hexadecimal number system, you can represent 15 as F. So final answer is here for 246 converted into a hexadecimal number, it is F6 value. Now you can take this 0.05 fractional part, just multiply this with 16. So what is the value you can get? That is 0.05 into 16, you can get value as a 0.8. So now take this 0 as it is and now take it as a 0.8. So here 0.8 into 16 is equals to, now multiply 0.8 into 16. So if you multiply 0.8 into 16, you can get value is 12.8. So just take this 12 here, and this next fractional part is here, again 0.8 is there, again multiply this 0.8 with 16. So you can get again 12.8, again shift this 12 here, right? So you can multiply like this, but 3 digits are enough, so I will stop here. Okay. So now this is as it is as 0. Now 12 you can convert it into a hexadecimal and it is represented as C, and here also C. So finally, so for this fractional part, that is 0.05, you can get 0 cc. So by final answer for this question is, that is hexadecimal equivalent of fractional decimal number system, that is 246.05 is equals to F6.0 cc and base is 16. So this is our final answer. Yes, so far we have discussed about the how to convert decimal number system to octal number system, decimal number system to binary number system, decimal number system to hexadecimal number system. Now we can move on to binary number system. So how to convert binary number system to decimal number system? Okay, so let us take one example. So this is binary number system. Why? Because here values are, digits are in ones and zeros. So if you take, this is 10 10 11, so this is your binary number system. Just this we need to convert it into a decimal, where base is, for decimal number system, base is 10. So for this one, what we have to do means, so each and every bit we need to multiply with 2 powers of 0, 2 power 1, 2 power 2 and so on, right? So like that, if you take this this number, so here, so 2 power 5 plus here 0 into 2 power 4 plus here 1 into 2 cube plus here 0 into 2 square plus 1 into 2 power 1 plus, so here 1 into 2 power 0. So like that, each and every bit we need to multiply 2 powers of zeros, 1, 2, 3, 4, 5, right? So after multiplying, just solve this one. 2 power 5 value is equivalent to 32, and here 2 power 4 into 0 is 0, and here 2 cube into 1 is 8, and here 2 square into 0 is 0, and 2 power 1 into 1 is 2, and 2 power 0 is 1. So after performing this multiplication, just add this all digits. So 32 plus 8 40, 40 plus 2 42, 42 plus 1 43. So if you convert binary number system, that is 101011 into decimal number system, what is the value means? Here 43. So let us take one more example. This time I am taking here after this fractional points also, that means 101, right? So if you take this binary number system, that is 1011.101, so we need to convert it into a decimal in the base of 10. First we need to solve this thing. So how to perform means, whatever I have explained in the previous example. just here multiply each and every bit with 2 powers 0, 2 power 1, 2 power 2, like that. Okay, so if you take this one 1011, so simply here 2 cube 1 into 2 cube plus 0 into 2 square plus 1 into 2 power 1 plus 1 into 2 power 0. So here 1 into 2 cube means 8. So 2 square, that is 4 into 0, 0, and 2 power 1 into 1, here 2. Here 2 power 0 means 1, 1 into 1, 1. So here finally what is the value? Here 11 is the value. Okay. So this part is completed. Now how to convert this one? So after this point, so if you take whatever this value is there, if you take here 101 value is there, right? So here also we need to take simple. So now we need to multiply each and every bit, that means 1 into here 2 power minus 1 plus 0 into 2 power minus 2 plus 1 into 2 power minus 3. So what is this equivalent value? So after this point, we need to multiply with 2 power minus 1, minus 2, minus 3 and so on 2 power minus n. If you take 101, so here 1 into 2 power minus 1 means here 1 by 2 plus this value is 0 and here 1 by 8. So after performing this 1 by 2 and 1 by 8, what is the value? Here 1 by 2 value is 0.5. So this value is 0.5 plus 0 plus, so 1 by 8 value is 0.125. After adding these two, what is the answer here? So 0.125 plus 0.5. So here 0.625 here is the answer for this part. So after combining these two values, that means, so if you want to take this total decimal equivalent of this 1011.101, just here combine this value, here 11 point, here what is the value here? 625. So this is our decimal equivalent of binary number 1011.101. So coming to next type of conversion, how to convert binary number system to octal number systems. So here if you take one example here, so find the octal equivalent of 101111. So here base is 2. So just we need to convert. So here 10111. So we need to convert it into a octal number system. So we know that octal number systems, so we are having values is octal number system from 0 to 7, right? So here we need to reference in octal number system like that 000, 001, so 010, so 011, 100, 101, here 110, 111. So this equivalent value is 0, 1, 2, 3, this is 4 and this one is 5 and this one is 6 and here 7, right? So for binary number system you need to take, so here 10111, just we need to take this direction. First we need to pair these three number systems. Next we need to take this one. Of course here there is no value means, so we need to put it as a 0. So what is the equivalent of this 111 in octal number system is, so 111 value for in octal number system is 7. So 010 is in octal number system is 2. So here we need to write 2. So finally what is the octal equivalent of 1011 of binary number system is equal to 27 with base 8. So in this way we can convert binary number to octal number system. So if you we can go with one more example. This time I will take this example. So here let us start with 1110.11. So we need to convert this binary to octal number system. So let us first start with this number. So what is this number means here? So here if you take 1110, so as I said earlier, so take this one, this direction and group these 3 bits and next group this one. So of course here there is no bits means we need to put here 00. So in octal number system 001 is equivalent to 1, In octal number system, 110 is equivalent to 6. So now coming to this, after this point, whatever the binary values is there, we need to convert this value into octal number system. If you take, so here 1 1, so of course in octal number system 3 digits are there, but here only 2 digits are there. We need to add 0 here, not here. Okay. So after adding here 0, now this value is equivalent to again 6. Okay. So finally, what is the value of this 111 0.11 is nothing but here 11 0.11 is equivalent to 16 point. So what is this octal equivalent of 11 is nothing but 6. So this is our answer, that is 16.6. Next, now coming to next number conversion, that is binary number system to hexadecimal number system. Okay, so as I already told you, in hexadecimal number systems we use digits from, in hexadecimal number system we use digits 0 to 15, but in 0 to 15 we use only 0 to 9 as numbers. From 10 to 15 we use A, B, C, D, E, F. This is 10 and B is equivalent to 11, 12, 13, 14, 15. Right. So now coming to this example problem here. So if you take binary number system, that is 1 0 1 1 1, here 0. So this is our binary number system. So we need to convert it into hexadecimal number system, means we need to go with in hexadecimal number system we have to use with A48421. So here in hexadecimal number system we use grouping as a 4 bits. So like that, if you take this one, so if you take this problem, that is 1 0 1 1 1, here 0 1. So go this direction. So let us take this 4 bits one side and grouping, and next bits are grouping. Of course here there is no bit is present here, just we need to put it as a 0. So as per hexadecimal number system, what is the equivalent value of 1101 means? So what is this value means? Equivalent value of 110 value is, I think this is 13, so this is 1, but we can represent 1 as it is 1, but here we can represent as 13 as D. Okay, so why? Because here in hexadecimal number system we can represent 13 with D. So final answer is, so 10 111 01 2 is equivalent to 1 D in hexadecimal number system. So here for hexadecimal number system, here base is 2, for binary number system here base is, sorry, for hexadecimal system it is 16, for binary number system it is 6. So let us take one more example. So how to convert again binary to hexadecimal number system. So here also same. So if you take 1 0 0 1 point, here 101 is the data, right? So here binary number system. So we need to convert it into a hexadecimal number system. So here also same. So first let us take with here this one, that is 1 0 0 1, here 101. So if you grouping these two, it is 4. So like that we need to group here after this point. So this equivalent value is 9. Okay. Next we need to group bits like this, but here 101 is there, but according to hexadecimal number system we need to group it as a 4. So just we need to put it as a 0. Now after converting this 1010 value, what is this 1010 value is nothing but here 10. So in hexadecimal number system, we can represent it as a 9, we can represent it as a 9. We can represent 10 in hexadecimal number is A, right? So finally, so what is the answer for this 1001.101 is, so if you convert this binary number to hexadecimal, its value is 9. So if you convert this one, its value is A. So 9.A is our answer. So far we have discussed about the what is number systems, and what are the different types of number systems, and how to convert decimal number systems to other number systems, as well as binary number system to other number system. In the next class, we'll discuss about how to convert octal number system to binary, hexadecimal and decimal, as well as hexadecimal to decimal, binary and octal. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.